Excellent. Okay, good. Great. Okay, so what we're going to do today, first of all, is I'll review a little bit of what we talked about last week, and then we'll talk about continue talking about prototyping, and hopefully today we'll get some time to do a small prototyping exercise in class, so we'll see how that goes. So last week I gave you Introduction to Interactive Design, and I used this definition from Jenny Priest, which comes from her interaction design book, that she said it's really about designing interactive products to support people in their everyday working lives. So it's all about the design of user experience with technology, and I gave you some examples last week. I showed you the Engage phone, and I showed you some video of the Reactrix system with the projected image on the floor and a few other things like that. The most important thing, though, is that interaction design is really about this conversation back and forth between people and machines. So the idea is to look at what happens over time when you're interacting with the technology, and also in the context of use. Because sometimes people try and design interfaces in isolation, they don't think about the context of use. And then I showed you the video from Bill Verplank where he talked about how it's really about answering these three questions. What do you do? So how do your actions affect the world? What do you feel? So what do you sense of the world when you act on the world? How does the world react? And then what do you learn from that? What do you know? So how do those three things fit together? And he talked about handles versus knobs and soft and hard technology. You get some good examples of that. And the probably most important thing from last week is this process here, where you discover users' needs, you design for those needs, and then you evaluate around those designs, and you keep on doing that over and over again. So in terms of needs discovery, I talked about a number of different methods for discovering users' needs. Can anybody remember any of those?
Questionnaires needs use.
Hmm? Anything else?
Just the ones I remembered.
Oh, the ones you remembered. And it's only two. I gave you about 6, so you think of anything, Timo?
Observation as well.
Observation is another one, that's right. So let's look here. So the most important thing when you're trying to discover the user's needs, you've got to think about the whole user. So sometimes when people are doing technology design, they think about whether or not people can reach the buttons or use the interface in a certain amount of time, which may reflect on their physical needs or maybe sometimes their cognitive ability. But you've really got to think about emotional and social and cultural as well. And so that's why one of the reasons why the Engage failed is that it made people look silly when they were using the phone, holding it to the side of their heads like that. So here's some ways to get some needs assessment. So we've talked about questionnaires and we've talked about interviews already. And we can also look at, and you mentioned observations, we can also run workshops or focus groups. We can look at existing documentation, so if people have a manual for some system and your job is to improve the system, then you can look at the existing manual and find out how it works. And another important way is through role-playing. So here's a woman who's role-playing, and she's testing out or trying to imagine what it's like to be a patient being admitted to the ER. Observation is really like this one where you're following around this old guy in the hospital in the store to imagine what he's like. But the cultural probes is another method too, where you give people items that they can use to capture what happens in their everyday life. So one of the examples I gave you was the camera that they gave out with the Equator project, where people were on the back of the camera, the disposable camera, they had written what they were taking photographs of. So, in summary from last week, there's these 4 basic activities: establishing requirements, designing alternatives, prototyping, evaluating. And then we really want to focus on user-centered design, so we're focusing on users early. We're looking at how to focus on users in their tasks, we're looking at how to measure how effective the interface is, and then iterative design based on that. So last week I also talked about personas, and how when you're designing for interfaces for people, you have to think about the persona. And imagine the end users using it. And I gave the example of Gunter, the ad guy. This is from Apple when they were designing for their new portable projector. So he was somebody who was always on the road, and he needed a projector to do business presentations. And then from this persona, you can build short scenarios that tell a little story about that persona, what they're doing. And then from that, you can put a storyboard that shows the use of technology in place. So here's Gunter using technology in place here. And then from there, you can build your wireframe mockup. And I gave this example of a, so the wireframe or the mockup is a step-by-step walkthrough of the interface technology. So that's kind of a summary of last week. So Martin, I guess you've probably done storyboarding and mockups before, is that right?
Yeah.
Okay. How about you, Timo? Have you done that before? Great. Great. The personas as well, but not you, I imagine. So that's all right, Michael. It's good to learn some new stuff. So what I wanted to give you today is continuing on to the next step of that. But first of all, I want to share a little bit of article, and I'll print this and I'll put this on the Learn to make it available. But this is a really good article that was came out in Business Week about 7 or 8 years ago, and this is an article about the firm IDEO. Do you guys know IDEO? So do you know Timo IDEO? Only one of three. Okay. So IDEO is probably the leading design firm in the world, or one of the top design firms in the world. They're based in Silicon Valley. And they've done a lot of the good products you've used may have come through IDEO and been designed by them. So some people who are doing interface design, interaction design courses, their dream when they finish is to go and work for IDEO. So they were founded by this guy Tim Brown, who's here, and David Kelly, who's here.
It says it's the other way around.
Tim Brown left and David Kelly right, yep. So, and this article gives a good description of how IDEO works. And in particular, and so I'll put this up on Learn so you guys can read it, but in particular, there's this IDEO way that talks about the 5 steps in building a better consumer experience. And so the first step, and we've talked about a little bit of these last week, but the first step is observation. So, the shadowing that we talked about last week is listed here. So here's how people understand the consumers at all. And so the camera journals is like we talked about last week as well. And then the second step is brainstorming, and we touched on that a little bit last week. So people go around and brainstorm different ideas. Then rapid prototyping. And then iterative refining, so they go back and essentially brainstorm and get engaged with the customer again, and finally implementation as well. So, so those are the 5 steps that they go through, which is essentially that same interaction design cycle that I talked about as well. And but what they look at is the whole user experience. So IDEO doesn't just do physical products. They look at the whole customer experience. So one example, so here's underwear department in a women's underwear department in a clothing shop. And one of the stores, I can't remember which one it was, Macy's or something like that, brought IDEO in to try and improve this experience. Because they say that when women go to buy underwear, it can be quite confusing experience. You can see here there's massive amounts of underwear on show, and it can also be very embarrassing and like that. So they redesigned it to be like this. So they kind of put this gateway here, so you walk into this part of the store, because sometimes the underwear section is mixed up with other sections in the store. So you're looking for makeup, and before you know it, you're inside the underwear section, and that doesn't give you a good separated experience. So they've got this, instead of having lots of underwear on show, it's only a few pieces. They've got they have the fitting department separate from the where the underwear's on show. They have a concierge, so that when you go through the entries department, you've got a woman that meets you here and can talk to you about it. So it redesigned the whole store.
A lot less product though there.
It doesn't matter if you sell more. It's like high-end BMW stores. There might only be 3 or 4 cars on show, but you know, they don't put everything out. So yeah, and of course they could have lots of product out the back. I think the idea of this redesign was that you start interacting with people more, and the people go and get the product that you need. So that's one example of how they did a redesign there. So here's some of the companies that have worked with IDEO, Lufthansa and Intel and Nestle. So I'll put this up on the Learn, and you can download it and read this. They've locked the PDF file, so we can't print it. I'm sure I can figure out a way around that. But anyway, but you can at least read it on the web. But it's a really good read, and I highly recommend it. So what we're going to talk about today is the prototyping process, which integrates into the next step of the scenario development. And then hopefully what we're going to do is have time to do a small amount of brainstorming and prototyping in class as well. So first of all, what is a prototype? So the prototype's a interaction design that can be one of these types of things. So it could be a series of screen sketches, a storyboard, a PowerPoint slideshow, a video, a lump of wood. So I showed you last week one of the ideas they got from the people was to have some wood with stickers on it to show people where to put the buttons, a cardboard mock-up, or even some software that partly runs showing the system. So these are all different levels of prototyping, I guess you'd say. And it's one of the things that we want to do in this class is focus mostly on rapid prototyping, because with design, the idea is basically to get as many ideas as possible out there quickly, and then get and build an artifact or instantiate some of the ideas so that people can give feedback and you can iterate around those ideas. So the basic benefits of rapid prototyping is it's very fast and expensive. It identifies problems before you start doing any coding or hardware development. It gets feedback from the end users, so when they see your rough sketch on a piece of paper, they can say, well, that's not quite what I imagined, or I want it bigger, or whatever else. It helps the developers start thinking creatively. It's hard to sometimes see something without an artifact, and it gets the stakeholders involved early in the design process. It also builds teamwork. So with IDEO, a lot of what they do is working in teams, and having some artifacts that you've developed gets everybody on board. It avoids opinion wars, because sometimes people will be fiercely wedded to some opinion, but they haven't drawn or expressed that opinion, so people can't discuss around that. And it helps decide design directions. I guess we've kind of talked about that already, so we'll skip over that. So there's several types of prototypes. So one is a low fidelity prototype, and these are the quick and dirty prototypes. And the second prototype is a high fidelity prototype, which typically starts involving more electronic versions and building materials.
3D printing come in that?
It would be more along the high fidelity. So what you might do is before you do 3D printing, you might, if you're tasked with building a new type of remote control for some fancy home theatre system. So what you might do for the low fidelity prototype, you might have a lump of clay and just mold it in the shape of clay, and that might take you 5 minutes, and you might generate a dozen different clay ideas, and then somewhere along the line you'll have to build some semi-working pieces of technology. So what you might do in that case is you might laser scan the clay to create a 3D model, modify the 3D model, and then 3D print it out. Current 3D printing is a little slow, so and you'll discover that later in the class when we do 3D printing. But yeah, we can do it. Yeah, and it won't be for about a month, but we'll do that.
Project was based around 3D printing.
Oh, was it?
Yeah.
Oh, cool, excellent. So with current 3D printers, that might take them typically an hour to 4 or 5 hours to print the object, which means it's too slow for rapid prototyping.
You have the dot ones with the colour, they just do a layer at a time and they're done really quickly.
Yeah, yeah. Well, we have a rep wrap.
Ridiculous experience. Yeah.
Yeah, we have rep wrap here in the lab, which is slower. Yeah, but we're going to try and get another one. We're trying to get it, well, something like a MakerBot a little bit later. But
Oh, that's
we'll see.
cool.
Yeah, yeah.
See, they've now got the 2-color one.
Yeah, yeah, that's really cool. So, so we'll talk about these, and of course, it's kind of a continuum. So, I should have made another slide, but you can imagine at one end you've got low fidelity where people are doing stuff with post-it notes, and the other end you've got high fidelity where you're using more electronics, but it can be all the way a continuum between that. So, in terms of low fidelity, this is oftentimes using sketching for sketching interfaces. You can use what materials are around you. You're doing team-based, and you use a lot to test out concepts before the design begins. So here's an example of a paper prototype with widgets. What they've done in this case is they've built or sketched out a paper version of a menu option or dialogue option in a system. And so they say, here, select the color for your message, and there's a pull-down menu. And then what they do is they ask the person to imagine pushing the pull-down menu, and they get a post-it note, and they stick the output on the post-it note so they can see the thing going down, and they can select red, and they've got the OK button there as well. So you can actually mock up going through an interface without having anything working. And you can see here's all the post-it notes going there as well. So let me show you a small video of building a video prototype of that. And where did I put it? Okay, so it's not there, but it's going to be in the directory here. And here we go. So this is a video from Bill Buxton, and he's has made a video prototype showing how our system works, and but he's done it with post-it notes, so it's quite simple. Okay.
I'm going to show you a trivial user interface to a perhaps even more trivial application. Yep, that was the whole thing. So now I want to show you, even though it's pretty obvious, what I actually shot in one stream to make them, what you just saw. So the first thing I did is stick down the post-it notes onto the tabletop so that they don't move. And likewise, put the camera on a tripod so it doesn't move. So everything's registered. Then I just went through page by page, that is screen by screen if you want, through the interaction sequence I wanted. Everything has to be registered so that the screens don't jump around when you go from page to page, or post-it note to post-it note. And just as I stuck the whole deck down onto the table, I'm using a material called blue tack, which is sort of like plasticine here, just to hold down the bottom of the page so it doesn't flip up, just to keep things flat. So from this longer sequence, I keep the parts that show me interacting with the sketched interface and throw away all the parts in between where I'm just getting things organized. The bookkeeping, if you will. So let's look at it again and see how it flows. And at the same time, just think, I keep the example trivial so that we can focus on the technique, the sketching technique. I find this useful when I'm learning the techniques as well as when I'm teaching them.
So this is just a little video prototype, but he's using sketching there, and it's just basically videoing the same post-it note process. Are you sure?
Assuming people don't know.
Yeah. So one approach is to use a card-based approach as well. So you can have a whole set of cards, and each card represents one screen or part of a screen, and then you can go through cards. And this is oftentimes used in 2D interface development or website development. Here's some interesting examples from Apple. So about 15 years ago, Apple developed QuickTime VR, and once you built the card-based prototype, you can actually start using that for getting some user feedback. So the great thing about rapid prototyping is that even when you've got a very rough interface, you can get some feedback from people. And so when Apple developed QuickTime VR, I guess you've all used QuickTime VR where you see a whole set of images on the screen. Well, you see what looks like a 3D object on the screen, but it's really a 2D image. And as you mouse over it, rotates around. You've all used that, right? You haven't used QuickTime VR? Well, you use something similar, I'm sure. There's lots of websites where you've gone to, and it says it provides a 360 view of the product, and what it really is a whole set of photographs, and as you mouse over, it'll show the photograph appropriate to which angle you're looking at. So that's QuickTime VR. So Apple invented that actually probably 20 years ago now. It's been a long time.
It says due to no confidential 93.
In 1995, so, or 93, yeah, so it's about 20 years ago. So when they developed that, the question they had was, which way are people going to move their mouse to rotate the objects? Because they wanted to be able to map, the mouse mode. When people move their mouse left or right, they want to be able to use that to load up the appropriate photograph. So one of the ways they did that was they, in this case, they showed two objects. Here's a Porsche car, and here's the Porsche car rotated 45 degrees. And this was one of their printed cards. And then they asked people, and they said, okay, we've got this technology now that lets you rotate objects on the screen. And we want you to imagine clicking on the Porsche and moving your mouse so you can rotate at 45 degrees. Which way would you move your mouse and draw on this piece of card? So they did that. And so in this case, they want to rotate the card 45 degrees. And almost everybody clicked and dragged the mouse to the left. So you can see there's lots of green lines here, and some of them aren't doing that. So this one is clicking and dragging down, but the majority are clicking on the car and dragging it to the left. So they did that, and here's rotating the car up and to the right. So they would basically show people this one and say, okay, we want you to go from here to here. How would you do that? And almost everybody clicked and dragged down. And similarly, to move the car from 0 degrees to the right. So in this case, what they're looking at is they were here. They were saying, well, instead of clicking on the object, what about if we put little arrows around the image and have people click on the arrows? And then here's an example of what about if we put a joypad or some sort of interface pad on the bottom of the screen? Would people click on that? And it turned out most people clicked on the image anyway. So that's an example of using cards to prototype with as well. And so even before they've cut the first line of code or anything, they understand now how it's working. So sometimes people also look at paper prototyping with hardware. So here's, some of you may remember the Palm Pilot, and the company or the guys that developed the Palm Pilot, one of their the company founders spun out his own company called the Handspring, and which was a competitor to Palm Pilot, and was wanting to prototype the user interface on the Handspring. But in this case, they had the Handspring MockUp, but they again didn't put the post-it notes on the screen of the MockUp. So if you were prototyping a user interface for an iPhone, you might have a physical iPhone and then put post-it notes on the screen of the iPhone. And then the next step might be to build a model prototype. So here's this is a project that Apple did as well to develop one of the first digital cameras. And this again was about 20 years ago. And so they built wooden mock-ups, and then they asked people to stick onto the wooden mock-ups. Well, they stuck on the wooden mock-ups different user interface elements like the screen and the buttons to try and imagine what they would look like. So here's two different alternative designs. This one looks more like a traditional camera. So they just a viewfinder and the lens there. In this case, they made it horizontal, and they put the lens coming out the side, and you'd hold it downwards and look down to it and shoot it that way. Because there's no need necessarily to have, with a digital camera, you don't have to have it looking like a traditional camera.
Surprisingly different.
It is.
And unintuitive.
Well, but this is more similar to what actually the final camera looked like. So you may not remember, but 20 years, Apple was actually the company that produced the first digital camera, the QuickTake, and it was more like this than the other one. I think I've got a picture of it later on. So here's a screen-based mock-up. So sometimes people developing websites will use Photoshop or some paint tool or something to quickly mock up what it's looking like on the screen. People will also do role plays. So here's a product where it was to encourage recycling. So the idea was that when you recycled cans, you would be able to spin these dials, and if you it was like a slot machine, and if they spun and if you got two matching products, you'd win a prize. So, but you're only allowed to spin once you put your can in the slot. So it's a slot machine, but instead of putting money in, you put cans in. And but they built a interactive role play. So they built a cardboard box with a hole in it. They put some cardboard cylinders there to do the dialing, and they could role play the user experience around that. Sometimes.
Did it get made at all?
I don't think so. I haven't seen it, but yeah. In Sweden or Scandinavia in particular, I guess maybe in Denmark they have, but there's a lot of recycling machines that go into supermarkets, but none of them are slot machines. They typically just have holes where you stick your cans or your bottles, and they give you a receipt, and then you go and get money off the.
Recently, I've seen some videos on the net from Volvo, like making experiences fun.
Okay.
Like one of their recycling ones was when you put it in, it played a tune.
Oh right, yeah.
Take the stairs, they put piano keys on all the stairs.
Well, I'm going to show some of those in a little bit later. I think maybe next lecture or lecture after, where, yeah, and there's some fun experiences in that. VW did something like that as well.
And maybe VW.
Yeah, no, it could be Volvo, but yeah.
For driving the speed limit, we did a lotto.
Oh.
It had like a camera, and if you're traveling at the speed limit, you got entered into a draw.
Oh, really? Okay, interesting. So this is another example. This is building a full-scale prototype of the Accelera train car. So so people built the train car, and then they had people sitting inside the train car. You could put luggage into the overhead bins to make sure it fit and all that kind of stuff as well. So that's getting more towards a high fidelity prototype. Actually, before I talk about that. Yeah, let me talk about, just to continue the train car a little bit. I had some slides to show you from someone else. I think it's this one. Let me see. Or maybe not. No, not these. This shows you the design process that New Zealand went through. Not this. It's number 2. There we go. So let's go on a little bit. So, okay, so in New Zealand, when they got their new 777s from Boeing, they wanted to design a new business class seat. So this is the final seat that came out, but I want to show you the process they went through to build this.
Is this the one you lie down and sleep on?
No, that's the an economy, and that's the it's also in the 777, but it's the couch, the sky couch.
I thought there was one as well that was like a wavy line. And
A wavy
basically
line.
There's a seat, and you can have a dinner with someone else, because like the table falls down, there's another seat.
Oh,
when the table goes down, they turn to a bed in business class. Or is that different?
That's different, I think. But yeah, yeah. But anyway, so this is so that's what the fun looked like. This is the design process they went through. So first of all, there was a lot of brainstorming and sketching. So you can see some of the sketching developed here. A lot of different ideas. So here's people sitting facing each other. Here's people more cramped in little pods built together.
There's someone climbing into the person in front of them.
Yeah, that's probably not a good idea. So they built this idea of people sitting opposite each other, looking at sleeping. So you can see lots of sketching, notes around the sketching. Here they had the idea that people could sleep at different levels. So you could have people sleeping low down, and their feet and heads would actually go underneath the people around them, and then so many people sleeping high up. Swivel chairs. And then when they built those sketches, the next step was to move to the next level of prototyping where they actually started doing CAD modeling and design. And in this case, they took into account the actual ergonomics of a person and how tall and wide the typical person is. Let me just get rid of this here. And then they built these mock-ups. So these are all built out of styrofoam. So you could, but they still mocked up. This is the width of the plane, and they built up a whole set to see how these would fit together inside the plane itself.
Wasn't the IDEO involved in that?
It may have been as well. I'm not sure. I'm not sure.
I think I saw a video of
Okay.
IDEO doing something similar.
Okay. I'm not sure who the design company was. It may well have been. And then they got. So this might be what we were talking about before about the sleeping. I mean, they could. You can sleep, and it is kind of a shape. You can sleep like that.
I think that's different.
Oh, is it different? Okay. And then you do support. They have this dinner configuration where these parts here can pull up, and then you can actually have dinner with each other face to face.
It's very similar, but it's more singular across the way.
Interesting. Maybe it's the
And
first
so
class.
So you've got 4 across instead of like 6.
Oh, right. Maybe it's first class rather than business class. So that's the whole design process they went through. So you can see from rough sketching all the way through to prototyping. So that brings us to high fidelity prototyping. So in the high fidelity prototyping, you're starting to use some of the materials that you might expect. It looks more like the final version. There's oftentimes software prototyping being used. Some of the dangers that people might think they've got a full system. So that means that they might start giving you feedback already about how responsive the system is or whatever, even though it's just a really high fidelity prototype. So some of the compromising is that, well, all the prototypes involve compromise, but for software prototyping, there might be very sketchy icons who might look at your rough drawings and say, well, that's not exactly what I imagined, or it's not limited functionality. So the typical two types of compromises that are horizontal compromise, where basically you generate lots of different options, but the options don't have much detail, or a vertical compromise where you generate lots of detail, but they don't have very many. There aren't very many options. So you have to kind of have this trade-off between the two of them. So here's an example of a half-functional prototype. So people, when they're building a website, might do a very rough HTML, and so in this case, you can actually interact with it, but the interaction flow is mostly pre-coded. People will sometimes use wireframing tools. So have you used any wireframing tools before?
No, not wireframing.
Okay, Proto, or have you used it all, or Timo?
Sure.
Okay, so let me show you. So, so there's a number of different tools, Proto or Wireframe Sketcher or OmniGraph, and a lot more. So Eclipse is a development environment, and Wireframe Sketch is a plugin that lets you build screens that fit in Eclipse. OmniGraph is for the Mac, and it's a graphing tool. And Proto is a very nice tool that lets you build interactive wireframes without programming. So let me show you their website, and I'll give you a bit more details about that. And we'll use Proto in one of our assignments. So let's go to the Proto website. So Proto is it's a design tool that runs on the web and also interactively. Let's watch their. Oh, that's not good. Let's watch their video if I can restart it. In fact, I think I have a video of. Oh, here we go. So Proto is one of those. Okay.
A website.
Crashed again. Oh. Let's be serious and try using Chrome. That might fix it. Yeah, I thought the sound went through the HDMI cable, but Well, I can just narrate. It's okay. There's no. Yeah. So I can just narrate it. It's okay. So Proto basically it's a one of those products where you can download the trial for free, and then if you end up using it, you pay a monthly subscription, and so this is what the screen user interface looks like, and then we'll watch the video tour. And you basically sketch out
Welcome to Pidoko, and thanks for watching.
Yeah.
Would you like to create better websites, desktop software, and mobile apps?
I'll just narrate it myself. So you basically sketch out the user interface on the in the application, and then you can connect stuff together. So here's the application here. So in this case, they're dragging and dropping and building a website for flights. So you can see they just dragged in a table there, and they've resized the table, and they can add some properties to the table. But it's very, very fast and looks like in this sketching style. And then you can add images and videos and other widgets. There's a whole selection of widgets you can do. You can build up a set of pages, and then you can link the pages together. So you can say, okay, well, when somebody clicks on this tab, we want them to go to this page here. But it's all done in the sketching style, so people who are using it don't get the feeling it's a final prototype. When you've sketched it up, you can then publish it to the web, and you can send an email invitation to try it out. So you sketch out your pages, you link them all together, you publish it to the web, and then somebody can log online, and they can try and use your prototype before it's
purposely wavy lines so people don't know it's a real site.
Yes, that's right, and so they get the feeling that it's just a rough site. So when people are using it, so you see this blue dot here. When people are using it, it also records their use as well. So you can also use it for some user feedback while you're doing it, and then you can also export out different specifications that you can build to. There's an integration between Pidoko and other programming APIs as well, and you can also use Pidoko to build for different devices. Yeah, so I'm not sure if they show that, but you can, so you pay $9 a month and you can use it as software as a service. But you can, but Pidoko has templates for iPhone, iPads, different other devices as well. So if you wanted to mock up an iPhone, so if you go here, for example, here's different templates they've got built already, and I'm going to show it. Okay. Well, they basically have a bunch of screens that are the same size as the iPad and widgets that fit with the iPad or Android devices, and you can mock up as well. So it's a really great product to rapidly build something that you can put in front of a end user. And as I said before, you can do usability tests already on the system, because as people start using Pidoko, they will record, it records already their interactions. But this is just one example of different products that you can use. I think I had another video, let me see that, of the wireframe sketcher. Although I might need to go back to the previous set of lectures for that. Okay, so here's one called OmniGraph, which is I showed you before, which is for the Mac. So here's a demo of OmniGraph working, and so you can make animated mock-up, and then you can publish it to iMovie to demonstrate it. So what they'll do here is they want to generate a gyro-nailed file sharing app. So the idea is two want to share a file. So you bang your phones together to share the file. So you create here's the design on canvas, and then you bump phones together to enable it. So drag the one phone, and you create a new screen. You then move it again, and you animate it, move it again, rotate it, Move it again. So they're doing essentially a cell-based animation, I guess. Bump the phones together, and then you put something here to show something's happening. Okay, voila. And now you can go back to the original, unbump them. So when the files are bumped together, then you should be able to drag the file from one phone to the other phone. And I guess this is really implemented in, I don't know, does iPhones do this? But I think Android devices do this for real, I can't remember.
No, it's just a lot like just doing something in PowerPoint.
Well, you see, it's a little bit different because when it generates the output, so what you're doing now is you're generating all the storyboard, like the screens, but then it'll generate the movie at the end. Which, so it's and it has richer interactions than PowerPoint has. But you're right. You could use PowerPoint
frame by frame.
Yeah, yeah. You could use PowerPoint something like this. So now that he's dragging the file over.
It's more like a combination between PowerPoint and Flash.
Yeah, it's like that. It's I would say it's probably easier than Flash, but it's but people do use Flash for doing mock-ups as well. If you're a proficient Flash developer. So now you can export it out as your images. And now you can use iMovie to create all the transitions and drag and drop all the PNGs in at the transition. So you could use PowerPoint to make a sequence of images as well, but now you've dragged and dropped it into iMovie. And there you go. And so after half an hour, this is what they've made. So now they have got a whole animated prototype that works. Yeah, so there we go.
Something very similar to PowerPoint.
Yeah, yeah, I'm sure. Well, there's a lot of tools you can use, but yeah. So so that's Omnigraph there. And there's also Wireframe Sketcher, and Wireframe Sketcher is it's another tool as well. I think Christoph is going to talk to you in a couple of weeks about Azure, and Azure is a very full-featured prototyping tool. But here's here's Wireframe Sketcher, and this one plugs into Eclipse, like I said, and it's similar to Proto. You basically drag and drop widgets, and then you can build interactive prototypes. Here's what some people have done with Wireframe Sketcher. So here's an Android application, and you can build the mock-ups, and it's got all the templates for all different things. Here's a typical website. There's a Facebook mock-up. Here's an iPhone mock-up. Here's a iTunes type mock-up. Yeah. So, and I can show you the video here. So it's essentially the same as Proto, but
welcome. Wireframe Sketcher is a rapid.
The interface is a bit richer, and it's yeah. With Proto, it all runs on the web, whereas with Wireframe Sketcher, you download an app and then you can you build it. So here, the person's going to start creating some different screens, and so you have all the screens along the top here. You can add the elements to them, and then you can, and you've got your assets down here. Each of the assets has different properties down here, and then here's your project screens here you're building. So there's a variety of screens that people built, and then you can, again, just like Proto, so he's dragging onto here an OK button. You can type some text in, and then he can link that to another page as well. So when you click on the button, it comes out, and you can then publish to HTML2, and then you can poke. So here's all their screens they've built together, and you can add links between the screens, and you can create a PDF or a PNG, or you can present it full screen or print out all the screens as well. And then it links to Eclipse. So when you've built it, then you can connect up to Flash or to Java or to one of your Eclipse environments like that. So these tools are very good, especially for user interfaces that are mostly 2D or screen-based interfaces. There's also some tools that will run on the mobile devices for prototyping. So have any of you used App Inventor before? So they've transferred it now from Google Labs. So actually, I think this link might be bad now. So now App Inventor has been taken over by MIT. It's become an open source product.
Yeah, I don't have an Android phone, so
That's okay.
pointless to build apps.
Well, you can still mock up. You don't have to have a phone to actually run it. So with App Inventor, the idea is, let's see if the link works. If not, I'll update it in the slides. It's a really great piece of software for rapid mocking up of Android applications. And there are equivalents for the iPhone as well. So let's see. Yep. So it takes you automatically to MIT, and then it fails to open the page. Interesting. Why is that not working? So this should be the new link. Yeah. And let's see. It's not. It's definitely still alive because I'm still getting email from the mailing list. Maybe it's just called it in this. There we go. The link was a little bit wrong. So it's not info. It's just appinventor.mit.edu. And then basically what you do is you download a small Java app that runs on your web browser, and then you can use this to rapidly build your own mobile apps with no programming at all. You don't have to have a mobile phone to build them. It has a simulator that runs on your PC or your Mac. So if you don't have a phone, you can run it on this emulator.
Not much point to run it because I have a phone to run my apps on.
Well, if you're a designer, you might want to design user interfaces that you can show people, and whether regardless you've got a phone or not, you might want to show them on the screen. So, let me show you App Inventor working. So they're going to build a silly little app here where the idea is to have a picture of your cat, and when you touch the picture of your cat on your mobile phone, it plays a sound file. So there's two parts to App Inventor. There's first of all you set up a project file, and then there is the design element. So here's a screen design, and this part is the second part is the logic part. So here's you plug your phone in, and so you can then drag and drop screen elements. So they're dragging and drop a button, and the button's going to have a picture of a cat on it. So there's the button with a picture of a cat appearing. And then they want to play a sound. So here's a sound, and then this is the logic. So you drag these logic blocks out. There's a button click logic block, and then there's a sound play. You put it into there, and you're done.
Like Lego Mindstorms.
Exactly. It's very like Lego Mindstorms. So you're finished. So now when you push the button of the cat, it's going to play a sound.
But in fact, they have a cat.
Yeah. So as I said, there's two parts. There's the Inventor Designer, and the Inventor Design does all the visual design, and then there's the blocks here which provides the logic. And you can either test it on an emulator, so it all runs on your PC or your Mac, or if you've got a phone connected, you can publish directly to the phone and test on the phone. But you don't have to have a phone; you can test it on the emulator here. The nice thing, though, as you said, is it's designed a little bit like Lego Mindstorms, in which case the logic here only fits together certain ways. So, for example, if you put a button click response, then you can see this green block here is shaped a certain way, you can only plug in certain types of objects into that, and then and then you can only plug in certain types of objects to that as well. So it's impossible to create errors when you're developing the logic, because only certain pieces fit together, just like Lego Mindstorms. In fact, they were inspired by the Mindstorms. Yeah.
I had the original one, which is connected with serial port.
Right.
I don't get those anymore, though.
So this is a very nice tool for non-programmers to rapidly build applications, and they will allow you to do connect to databases. They can connect to the camera, so you can create camera widgets, and there's a very large developer community as well. So if any of you are ever doing any mobile work and you want to do some mock-ups, you could use this as well. As I said, there's similar tools for the iPhone, and here's a whole bunch of different prototyping tools here for the iPhone as well. So what you typically do is you'd use App Inventor to build and test out the user interface, and then when it's working, you can actually publish apps you build with this to the App Store, but they run quite slow, and they have limited functionality. You couldn't use this to build a 3D game because there's no support for 3D graphics in this. But once you've prototyped it up, then what you can do is go back and then code natively the app up, or pass your app to a developer and say, build this.
Will it publish the code for you, but it's already used there?
No, it doesn't publish any code at all. So you can't hit a button and generate Java code or generate Objective-C, for example. It doesn't do that.
Okay.
Yeah. Yeah, but the idea is that you can take 5 minutes and you can build something and test it out, and then and iterate it over and over again, and then when you've got it the way you want it, then you can go and test it like that. So here's another example of a high-fidelity prototype. This is also continuing on from the same example I showed you before with the digital camera from Apple. So 20 years ago, Apple was building a digital camera. They wanted to be able to mock up and test the camera, but in those days there weren't any cameras around. So they built this high-fidelity prototype, which basically was a LCD screen and some buttons and dials with connected to a Mac here. The Mac did all the program processing, and they showed the output on here as well. So we've done that in that lab, in fact. So a little while ago, we were doing some prototyping for. We wanted to do some augmented reality on mobile phones, but it turns out it's very difficult to program mobile phones, especially 5 or 6 years ago, before iPhone and Android devices came around. So what we did then is I found a USB keypad that looked like a phone keypad, but it was USB, and so we could plug that to the PC. We took a small LCD panel that had a composite video input, and we glued that onto a box. And inside the box, we put a web camera, and we had some other sensors as well, and then plugged that all to the PC. So what that meant was that we could rapidly prototype on the PC using Flash or Visual Basic or even PowerPoint, but show the output on the phone. And so people could then prototype the interaction styles on the phone.
You invented the smartphone.
Yeah, well, not really, but yeah. So.
All of that very well.
Yeah. Sometimes people also do what's called Wizard of Oz prototyping. Have you heard of Wizard of Oz techniques before? Do you have? But you guys haven't. Wizard of Oz? Yeah, okay. So with Wizard of Oz, you basically invent future interaction methods with a computer, and you have a real person who implements those techniques. So, for example, in the lab here, we've done some work with speech and gesture interaction. But instead of having a speech recognition system that really works, we told the person using the system that we had speech recognition. We had somebody else sitting behind the scenes that's pushing the buttons and making the speech recognition actually work. Yeah. So that's a Wizard of Oz technique. And again, you can...
almost a reverse Turing test.
Yeah, right. But for the person who's using the software, they didn't know. So we had a system that we said you could point, in our large vision space system, we said you can point at objects and give speech commands, and they will change colour depending on what you said. And they said you can use whatever you want to talk to them. And then we had somebody sitting behind them with a keyboard and mouse who was clicking on the objects and changing the colours right away. And the person who was using the speech recognition system was amazed because they thought it was working 100%, and they didn't know that it was this other person. but we did that in a way also to collect data. So the other reason why we did that is that we wanted to find out what typical speech commands people would use. So just like Apple used with the QuickTime, where they had people drawing on the screen to find out what mouse commands they would use, we used that to find out what speech commands they would use and build up a speech set compiler. So here's typical iterations for a hardware or software product. You build a prototype to evaluate the conceptual model. You build an interactive computer-based prototype with very rough screens. You might have a tethered prototype where we've got all of the logic running on a real computer connected to some physical device, and you have most of the major features working. And then you have a real device that's a rough prototype with all the features working and the graphic design implemented. So I want to show you a couple of case studies to show that situation happening, and then we'll try a little bit ourselves. So this is the case study of Apple with the digital camera. So the Apple had the idea 20 years ago to combine a computer with the camera and to add in some different features like stylus input or sound or storage. So here's the rough physical prototypes they put together first of all. So you've seen this before already. Then they did some sketching. This is the sketching, actually I should have shown this before. This is the sketching they used to think about how the system would work. So there's their camera component, there's a viewfinder component, the screen, some buttons, display output, and this is all connected up to a Macintosh computer that actually runs it all. So this was the inspiration for this piece here. So it's a sketch there. Here's the high fidelity prototype to communicate visually.
A bit bigger than they intended it to be.
Yeah. And here's another version of the high fidelity prototype. So they want to have a stylus input with the screen. So here's the screen stylus, here's the buttons, here's the display. But then again, also all the electronics are done remotely. And now this is a 3D printed version to look at different physical designs. Do you want your camera to have a gap here so you can wrap your fingers around it? Do you want it to be connected? Do you want to have these flat buttons on top or round buttons? And here's what the final thing looked like. So obviously still quite different from here, but this was the very first digital camera invented. In fact, I remember using this in the early 90s. But you can see the design elements still there. They've lost the screen, but they've still got the camera being horizontal, and there was a small LCD display on the back here.
What did it cost?
It was very expensive. It was cost around $500 US, I think, in 1996, and it was a 2 megapixel or 1 megapixel, 1.3 megapixel.
That's fairly hard.
Yeah. And it was pretty popular. Yeah, but it had a black and white screen on the back, and it was I think, yeah. Anyway.
How many pictures could it hold?
12, I think. So it was, But when we used it in our lab, we loved it because we would make mock-ups and stuff and take pictures of them right away, put them in our paper. It was great, fantastic. And the only alternative at that time was to use a real camera, blow the pictures up, scan them on a scanner, and this whole process. So, but Apple got out of the digital camera business pretty quickly. I think they licensed the technology to Kodak or something, and they did other things. So I want to give you a more detailed design case study as well. So again, remember what we did before, where you've got this design, evaluate user needs, design around the prototype, and then go back around this loop. So this case is a augmented reality prototype for a outdoor museum. So this is actually a project from a woman who's doing the Bachelor of Science in Digital Media Design. This is her final year project, so this is her capstone project. No, this is in a university in Ireland. So unfortunately, Canterbury doesn't have a digital media design program. But anyway, so I think most of you know, well, from my AR class, most of you know a little bit about AR now, and you've seen how you can use mobile AR systems to guide you around outdoors. So her idea was that she wanted to build a system that would help with this museum. So in Ireland there's this place called the Bunratty Folk Park, and basically what they have is a collection of old buildings that are 150 years or so old, and you can walk around through the buildings and they tell you what life was like in Ireland in the mid 1850s or 1820s and that kind of period of time. So it's a living museum, if you like. They've taken buildings from all over the island and put them onto the site. There's 30 buildings that are there to try and recreate a rural village. And so what they wanted is they wanted to build an augmented reality experience where people could walk around the site, and they could point their cameras at a location, and they would recognize the location where they're at, and they would show 3D virtual content on site that would provide a guide. Because currently they just have plaques on the walls or printed paper, and it's not as interactive. So it should lead to this dynamic combination of live camera view and information. So the navigation aid they wanted to build it around was the current smartphone platform, and that's because most people have phones and they're comfortable with them. It's also good for the theme park because they don't have to rent out devices, so they assume most people either have an Android or an iPhone, and they can download the app for free and then walk around it. The phones have tracking, they have wireless communication, which then facilitates location-based commuting. They also have a large display as well. So first of all, designing for the visitor. So the first thing they wanted to do was to focus on user-centered design. So they wanted to understand what visitors did when they visited the park. So the goal was to provide something that's easy to use, that was useful, create an interaction between the visitors and between the elements in the theme park, and engage the visitor. And but they also had to ensure that the visitors understood how to use it, and they had to identify the visitors' motives. So there is some background literature research, and they've looked at what had been done in similar museums, and they looked at interaction design in outdoor museums. They'd also looked at trying to understand the user's interaction over time, and they did that through observations and through interviews. So essentially, followed people around. And so some of the findings were, when they by doing that, so the person went to the theme park, spent a few weekends there following people around, talking to people. They found that most people didn't use the maps, so there were maps available from the information centre. People mostly found people had mobile phones. They found that people who were visiting wanted more information. They wanted to be able to walk around at their own pace. The information should be straight to the point. And there's also a lot of social interaction. So I guess most of you have been to theme parks. Oftentimes you go with a group of friends and you'll talk about stuff with your friends. That was some of their findings. So based on that, they wanted to find what the user's goals were, and they defined the functionalities, and then develop some personas, develop scenarios around the personas, and then build up a storyboard as well. So here's some of the functionality they defined based upon the user feedback. So they wanted to be able to have different view options: a camera view, a map view, and a list view, with some different sub-options. And they wanted to have some augmented reality features as well. So with augmented reality, you could show 3D objects, you could show a tour guide, you could place buildings in place. So here's the storyboard. It's a bit hard to see, but the person arrives at Bunratty. Stacey, Jack, and Jill arrive. There's a Halloween festival going on. There's some events being shown, and they go to the castle. And when she's at the castle, she can pull out her navigation aid, and then there's an option to explore the castle, to take a tour, or for kids to play games. So when she pulls it out and she points the phone at the castle, she'll see a augmented reality pop-up icon appearing on the phone, telling about what is happening at the castle, about the castle. So you can see these are very crude sketches, and the person's not really the best drawer in the world, but it doesn't matter because it still tells the story. And then, so here's some different events being listed. face painting, whatever, she can go to the main menu, hit on the kids, see what's happening with the kids, and then when she gets close to the castle, it shows a fun fact, and it provides a quiz, so you can ask a question and some responses, and you can guess to see if it's got the right answer. When they get to a house, they can see some 3D content, and an augmented reality character appears, and it starts giving a narration about the house and telling what's in the house, and tells a story. She now wants to use a navigation aid, and navigation aid allows you to, the other person wants to play with it, and now they can capture the images, and they can draw their own colours on the pictures as well, so it's kind of a game there. So that's a storyboard showing different functionalities appearing.
She's still doing it.
Oh, you'll see. There's more slides to come. So that was the initial idea. Oh no, it's the same. So now the interactive design process. So she's done the storyboard, so now she wants to build low fidelity and high fidelity prototypes. So the low fidelity prototypes around using sketching and paper prototyping, post-its and PowerPoint. And the high fidelity prototype was to use some software called WikiTude. Has anybody heard of WikiTude before?
I think so.
You have, but you guys haven't. Okay. So WikiTude is on my phone. I'll show you when we get to it. Well, I have some software called Genio, which is a competitor to WikiTude. WikiTude is basically an AR browser that runs on the mobile phone. So the challenge that she had is that she wasn't a programmer, so she wanted this whole thing without doing any programming. So let's bear that in mind as well. So we'll look at the different prototypes she did. So here's some initial sketches. So she just went into a graphic design program and just did some mock-ups. So here's what the first screen could look like. Here's a mock-up of the camera view, and here's a 3D map. Here's a list view appearing. So the good thing about this was it's really good for idea generation. The bad thing is that you can't. This is done in Photoshop, and Photoshop isn't fast enough to provide interactive feedback. You can't click on icons on Photoshop and have them change to different images. But anyway, she generated all the pictures with Photoshop, and then she went to post-it prototyping. So just like I showed you before with the video sketching, she made a sketch of the underlying screen, and then she could put onto the screen different widgets and have people push or pretend to push the different buttons and then swap out different post-it notes to try to do different things. So this is her initial mock-up, and then what she did is she added on top here a home button that will let people quickly go back to the home screen as well, and looked at having different colours of buttons. And then from there, the next step was to build a PowerPoint prototype. So it turns out with PowerPoint, you can indeed link different slides to different regions on the screen. So she could then build the PowerPoint mock-up, and she could have people poke the screen. So the benefit of this is that you can now do real user testing. So previously you could, with the post-it notes, you could tell people to touch the post-it note, then you just quickly swap it out, but it's not quite the same as actually having the device here. So you can do real user testing. And so she did user testing with 15-minute sessions where she had people do it, and she used a talk aloud technique, which I think Andreas will talk about later on. And she could take notes, and she could do a post-experience interview, and she could actually do some user surveying. The other benefit of PowerPoint is that you can quickly, easily arrange the slides, so you can move around the screens as well. Then the final step, the high fidelity prototype, was WikiTude, and let me show you on my phone. I do have WikiTude on my phone, I think. Let's see if it it's been a while since I've run it, so we'll see if it's still alive.
You've changed the buttons around.
WikiTude, one of the issues is that you can't change the screen. So she could, so in her case, she'd put the buttons like this. But with WikiTude, because you're running their application, you can't modify any screen elements. So it was a way for her to prototype what it would look like to see virtual tags appearing, but the screen elements weren't exactly what she'd done before because she couldn't change the screen. So here's WikiTube running on my phone, you can see there. And if you've got an iPhone or an Android device, you can download WikiTube. It's a free download. And then from here, it's basically an AR browser. So if I click on one of these icons, like Twitter, I can click on this, and it will turn to a live camera view. You see the camera view starting up here, and it will provide a augmented reality overlay onto the live camera view. And it's taking a long time. Oh, it's loading. Here we go. Still loading. So it was a way for her to use another piece of technology to mock up what the final effect would be like. But when she got people to use it, she told them to kind of ignore the interface elements, just to look at what the AR piece looked like. So WikiTube's an AR browser, and is it going to work? Oh yeah. So you can see here is appearing little photographs, and I'll pass it around so you can try for yourself. And if you touch on these, then it will pop up a tweet message. So these are geolocated tweets. So you can look around, you can see where tweets are, and you can try. So WikiTube's an example of a AR browser, and so if you just wrote a little bit of PHP code or server code, you could add your own tags in space. So what she was able to do is go to Bunratty Park, add the geolocated information, and have people walk around the park and have the tags popping up. And actually in the AR class, we're going to have a whole class on mobile AR and browsers and stuff, so you'll get a lot more information. And so with that, people could do user testing. So she found people liked the technology. It was easy to understand. Participants could play with it. But it wasn't her final design. It only showed the AR piece. So the final design concept, what she did is she built a final mock-up, and then but she couldn't code it. So what she did is, so here's the final mock-up of what the design looks like. You can see it's an evolution of what was on the. If I go back a little bit previously, you can see it's an evolution of what's on the PowerPoint. So here's the PowerPoint screen, and here's her final design. Still has the same icons in the same place, but now the icons are looking much nicer, and she's got these virtual 3D tags appearing.
Just got rid of the kids button.
Yeah. Oh, yep. And then what she did is, because she couldn't code, she basically built a. Oh, thanks, Michael. She basically built a video prototype, so people could watch the video and give feedback on that one. And of course, with a video prototype, you can go into iMovie or a tool like that and build a very nice evaluation. So that is the whole prototyping process. What I want to do now is...
Do you get someone to build it properly? And it's
I'm not sure. I'd have to go back and have a look. But there are other technologies like this in the market, so people have gone back and built similar systems. So what I wanted to do now is do a small brainstorming prototyping exercise with the three of you. And this is going to be difficult to video, so you probably want to stop the video recording. But so for the next 20 to 30 minutes, we'll work on this, and then this is going to be the first assignment for the class. So what we'll do is we'll start it now, and then over the next week and a half, you'll continue working on it on your own, and the goal is to basically build a video prototype like what she did using it here. So first of all, let me set the scene, and then we will do some design. So the basic idea is that we have a lot of people who come to the HIT Lab, visitors. And when they come to the lab, they want to find out about the people in the lab, about what we're doing. And so we have, at the entranceway of the lab here, we have this photo board, that, and your photos are there. But right now, it's kind of a stupid photo board. It just shows the pictures of who the people are. What I want to do is turn that into an interactive photo board that could be used for several things. So one thing would be to be able to have more information about the people other than just their pictures and their names. So potentially you might be able to touch on a person and have some feedback based on that.
You want to turn it to a touch screen sort of thing?
Well, maybe. There could be a number of ways to do that. So one need is to be able to provide more information about the person. A second need is to provide information about what project the person is involved with, and there could be several people involved in certain projects. Our third need could be to provide information about whether the person is in the lab or not. So, for example, a kind of a selfish need of mine would be I would love to walk outside my office and look at the photo board and have lights or something on the photo board showing whether the people are there or not. And somehow in the lab we'll have some sort of monitoring technology so we'll know whether somebody's there. So, and we also want to be able to use that to showcase some innovative interaction technologies, because we're an interface technology lab and people come here, they should have something more impressive than just the photo board. So let's go and have a look at the photo board we've got now.
I just plotted something out in my head.
Good. Well, that's perfect. That's great. But one of the important things is, well, what we're going to do now is we'll look at the photo board and we're going to talk about it, and we're going to do a small amount of brainstorming, because one of the important things about the brainstorming process is not to get locked into one design in the first minute, because you can immediately think, oh, great, I want to have a touch screen with photographs of people, and you touch the photographs, and it expands out to web pages or their projects, and we're done. But it actually might be that there could be some other technologies that might be able to use as well. So what I want to do is spend the next 15 minutes or so going through a brainstorming exercise to brainstorm all the different possibilities. And then over the next week and a half or so for you guys to then go through the sketching process and the scenario process and actually put together a video prototype of what the system would look like. So let's go and have a look at the photo board and we can talk more about it.